Good evening, everybody. I guess everybody is able to hear me loud and clear and also see my screen properly.
Yes, sir. Good evening.
Yes.
Okay. Good evening,
Good
sir.
evening.
Yes, thank you, sir. Thank you.
Good evening,
So,
sir. All
good
visible?
evening, sir. Yes, sir. Still alive for you people. Thank you. Thank you. So, let us start our session. 15 people have joined, rather 14 people have joined. So let us start our session for today. And let others join in the meantime, because there are quite a few things that we have to cover today. We will continue with our major phase today. We will continue with our major phase today. We will first work out on the Minitab exercises for MSA, measurement system analysis, which we understood yesterday. We will first do those hands-on, and after that we will understand the concept of process capability. As I told you, that always I first explain the concept and then I go to the Minitab exercises. Otherwise, just doing a Minitab exercise might not always give you the clear understanding. Okay, so this is the way I always teach. Then after process capability with some touch base on some other areas, then we will step into the analyze phase for today. And then we will proceed with the analyze phase. Okay, so let us, without going into further discussion, what we are going to do today, let's start our session. So welcome once again. Good evening and welcome all of you to today's session of the Certified Lean Six Sigma Masterclass. Today we are going to continue with our major phase and ideally with the measurement system analysis we will do. Now in the green belt session, what we ideally do for the measurement system analysis, we just understand the concept. We understand the concept and with some examples. Also the process capability, we understand the concept with some examples. We necessarily don't do the Minitab hands-on, ideally in a green belt. But in a black belt, at least in my session, and in a black belt, what we do not only the understanding of the concepts, but also we do the Minitab exercises. So before we step into analyze phase today, we will already be touching base on 4 hands-on exercises today. Okay. So before going into this measurement system analysis, so a quick recap of what we discussed yesterday. Okay, somebody's chatting. Shahin, we will talk about this later on. Okay, we will talk about this later on. Don't keep on chatting with me when I am present. Okay. So what we will do when we are talking about this measurement system analysis, we discussed that whenever we measure and find out some data, when we measure some data, ideally, if that is the same data, if I give to one of you to calculate, measure it number of times, ideally, the result that you bring will ideally be the same all the time because it is the same data, same measurement unit, and the same person is measuring it multiple times. So ideally, there should not be any variation in the output. But sometimes we see that there are, due to some reason or the other, we don't go into an analysis to find out what is the reason. But in the measurement system analysis, we try to ideally find out why there is a measurement variation. Sorry, how much is the variation? That's what we try to find out in the measurement system analysis. That is, how much is the variation in the measurement, and based on the criteria that is set for each and every area, how much of the variation are accepted. Okay, so that's what we are going to see today. As we understood yesterday when I explained that for a continuous data, ideally, for measurement system analysis, the result will always appear in percentages. Okay, this is in line with almost same like the way we discussed for probability distribution, where also the results we get are in percentages. Okay, so measurement system analysis, we get a percentage. If the data is a continuous data, we get a percentage figure as an output that we will see today. And when we have an output, we first check the percentage. If it is less than equal to 10%, that is excellent. That means less than equal to 10% means 90% or more is the accuracy in the measurement. So 10% is the variation. So any of this measurement we will accept. We will accept that. Okay. Now, if it is 10 to 30%, in those cases, organizations has to take a decision whether we will still go with this analysis or measurement or not. That's a marginal thing. And if it is obviously greater than 30%, if the variation is there greater than 30%, that means what? The accuracy in the measurement for a continuous data is less than equal to 70%. In those cases, surely we are not going to accept it. So in those cases, what we will do? We will go for another way of doing a measurement system analysis with some other data, or we might get some other people to do the measurements. Okay, so those are different things. Now, for a discrete data, we have learned that if the percentage is greater than equal to 80%, then we will accept that. So you see, as I told you earlier also, we will learn few of these things again in the analyze phase. Ideally, in statistics, we will expect 100% result, which is ideal, definitely ideal. But even with 80% accuracy, even with 90% accuracy, we will accept the result based on different analysis that we do, which we are going to start with the measurement system analysis. Okay, so these are the areas we learned yesterday. We also discussed about one very, very important area yesterday in the measure phase, which is the concept of variations. And as I told you, variation is always considered with respect to the mean performance. Variation is always considered with respect to the mean performance of a process. We first calculate the mean and then we check how much are the variation compared to the mean. Okay, so variations, as I said, in any good process, any consistent process, any stable process, always variation should be as less as possible, because I told you that there are two objectives of a Six Sigma initiative that we do. Number one is to reduce or remove defects and problems from the process. And the second one is reduce variation from the process. We cannot remove, ideally, all the variations from the process. Okay, some amount of variation this way or that way will always remain. Now, the variations are always of two kinds. One is a common cause variation and a special cause variation. Common cause variations are those variations which are common in nature, which are obvious in the process, which I discussed. Common cause variation should always remain in a process. Sometimes we can also have some special cause variation coming out in a process. There could happen, right? Some abnormality in the data sometimes. So whenever there is a special cause variation, we have to identify that. We have to analyze that, why this is a special cause variation. As I gave you that example yesterday, we have to analyze, we have to justify that because of this reason, we conclude that this is a special cause variation. As because I am a black belt, as because I am a green belt, as because I am a master black belt, I am saying this is a special cause variation, I will remove it from the data. This type of rationale will not work. It has to be very much well rational. That means you have to put it in a very good way why you feel that this is a special cause variation. So the justification has to be documented. And after that, I told you the fourth step, remove the special cause variation from the data. And when your data, the special cause variation data is removed from the data set, your data now has only common cause variation ideally, which is a normal variation. So your data is now called a normal data. And ideally, in green belt, we don't discuss this too much. In a black belt session or in the master class, we discuss it more for ideally for the people who strive to be a black belt. That ideally in Six Sigma or statistics, what we do, we ideally use this one, Just give me a moment. Okay. Some people are just continuing writing on the WhatsApp group. I don't know. When the session has started, they should stop communicating in the WhatsApp group. They cannot get a solution like this. Okay. So what I was coming to that when a special cause variation is removed from the data, your data becomes a normal data, as because ideally Six Sigma and statistics both appreciate a normal data. Okay, there are few cases which I told you that we discuss in a master class only, that one. In few cases, even with a special cause variation, we will do some of the statistical analysis, which is 1 to 2% of the cases. Otherwise, we will always accept the normal data. Okay, so now based on all these discussions, then I will proceed today with our Minitab exercises on DHRNR or the measurement system analysis. Before I go ahead and start with our exercise, any doubts or questions from anyone on whatever we have discussed till now? Okay, now let me see what Shaheen was writing on some Minitab problem. She is writing to me, but when I click calc, I'm not getting the option of binomial distribution. I'm able to see cumulative distribution function. Shaheen, could you please talk to me? Could you please talk? Because I cannot keep on chatting with you. If you can talk, yes, Shaheen, you have to talk to me. You have to unmute yourself because I want to understand, do you have an Apple laptop or a Windows laptop? Ideally, if you have a Windows laptop, it should not be any problem. Do you have an Apple laptop?
Yes, I have an Apple.
So you are having an Apple laptop. In an Apple laptop, sometimes the options are a bit different. Okay, so you have to match it. And because I am mostly used to, because 98%, 95% of the people who use Windows. So you have to try it out. Okay, for a calc, there should be a binomial distribution. You have to check it. Okay.
It's giving me when I click on calc, I have probability distribution, and then it directly gives me cumulative distribution, inverse cumulative distribution, and probability density function. It does not give me the
try with the cumulative distribution function. Try with that.
Yeah,
try with that.
Okay.
Try with that. Let us not discuss further on this because we have already done this yesterday. So try with that. If you are still not done, tell me again tomorrow. Then we will probably try to see one. Okay. Because Apple, yeah, no problem. So Apple, the menus and everything is a bit different. That's why I asked you whether you have a Macintosh or an Apple laptop operating system. Okay, so let us now start today's Minitab exercise on the measurement system analysis or DHRNR. Before doing this one I want to do with Chetan. Chetan, you have your Minitab? Chetan? Request everybody to kindly respond on time. Okay, I should not keep on calling you.
No, sir. I do. Today I logged in from my mobile. I don't have Minitab.
Okay, but I told you people many times not to log in from your mobile, because if you log in from your mobile, you people are missing out the opportunity of your practice. But that's fine. It's your call. Okay. What about Pit? Pit, you have your Minitab, right?
Yes,
Yes,
I do.
So we will do. Yes.
I'm sorry, Debasish. I have a very important errand right now, but I'm just listening to you. When I get back to my apartment, I'd be able to do the Minitab demo.
Okay. Can't help them. What about Uruj? You also have some problem, or you will be able to do it? Yes, Uruj?
Yeah, I'll do it, sir. I'll do it.
Okay, sir. Okay, sir. Thank you. So let us do with Uruj. Look, I want that everybody should have a fair chance of doing some practice. And if some of you have some problem or the other of not able to access or having some problem with Minitab, I can't help. So I have to go with people who are doing it. Okay. Okay. So let us understand this exercise first. Let us, all of us, read this. Given the data below for reading by 3 appraisers on 6 calls with 2 trails, determine whether the measurement system is acceptable or not. The thing is, there are 6 call IDs. Each there are 3 appraisers. There are 3 appraisers who have been asked that please measure this call duration 2 times each one of you. Ideally, call ID 1, when appraiser 1 will measure the call duration in minutes or whatever, call duration, the first time he does and the second time he does, ideally it should not be different because it is the same call duration he is measuring. But in each case, you see there is a difference with A, B, C, everywhere there is a difference. So we have to now understand from this data whether the measurement system is acceptable or not. That's what we have to understand. Okay. So what we will do, I will stop sharing my screen and I will make Uruj. Where is Uruj? Yes, so I will make Uruj the co-host. Yes, Uruj, I have made you the co-host. So please open your Excel data file first. All of you open your Excel data file. One Excel data file has been shared as well. Open that Excel data file first. Share your screen and share with me the Excel data file.
Okay. Just hang on.
Mhm. Everybody should keep Minitab and the exercise data file ready with all of you. Okay, because from this hands-on onwards, we will be using our Excel data file. No further data to be entered. Okay, because we have already entered yesterday. I have shown you how to enter data. From now on, we will be, because their number of data points are more. So we will be using the Excel sheet, which I have already.
It says host disabled participant screen sharing.
No, cannot be. I have already made you the co-host. How can it be, man? Okay, just give me a moment. Yes, I have also stopped sharing my screen. You are not able to?
No, it says host disabled participant screen sharing.
Okay, let me make you the host in that way. Let me check. If I make you the host, in that case, can you now do this?
No, again it says host disabled participant screen sharing.
Very strange.
Let me check from my mobile. Let me check.
Check from where?
I am checking it right on my PC, but it says
Yes.
host disabled
No,
participant screen sharing.
you have to check it on your PC only. Mobile will not.
Yeah.
Mobile will not.
Yeah. So I have opened. I have opened the Excel sheet, but again the problem is coming up with
very unique problem. You do one thing first. You do one thing first. Right click against my name and make me the host back.
Okay, just hang on.
Right click against my name and make me the host back. Let me try with somebody else. Right click against my name in the screen, yes, and make me the host. It worked yesterday, fantastic. No issues. Why it should? Yes. So I don't know what is the problem with Uruj, why it is happening like this. Can we have this with Satish? Satish, you have your Minitab?
The mobile, my laptop will be stacking there, sir. Company laptop will be there. All already will be blocked will be there.
Who has his Minitab? Who will be? What will be? Yes.
Devashish, can I share my screen?
Absolutely, sir. I will make you the host. Just hold on. Just hold on. Just hold on. I will make you the host. So I think we are wasting time asking people if they can share. Please check whether you are also having that same problem or not. I don't know why it is the problem.
Yeah, I can share. Okay, so
Open the Excel sheet.
yeah.
Yes. So I don't know what Uruji is having this problem. I don't know why. Okay. Now we have to select the data. So all of you open the data. Now, who is doing this? It is Mehtab. Mehtab, please come on the right hand side. I will tell you which data you have to select. Come on the right hand side. Move your cursor on the right. Yes, yes, yes. No, 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 it is gone. Okay. Now slowly, slowly come on the left. Slowly. Yes, hold on, hold on. Hold on, hold on. Column AL, column AM, and AN. Hold on, hold on. Don't be so fast. I am telling you how to copy. Copy with the heading, not from AL. Copy from the heading. Copy from the heading, yes, and copy till the end of the data. Yes, copy till the end of the data. Don't copy any blank rows. Don't copy any blank rows. Yes, copy. Go to your Minitab. Show us your Minitab screen.
One second.
Yes, yes, yes. You have to click on New Share. Then only Minitab screen will appear.
Okay.
Click on New Share. Open your Minitab.
Yeah.
And paste it now. Take your cursor just below C1. Yes, absolutely. And enter from there. Yes. So all of you have probably entered, copied the data, call ID, appraiser, and the data. These are the data which is given to us. Now, based on this data, we have to understand the measurement system analysis. Okay. So what we will do, all of you, please follow Mehtab. Mehtab, please go to Stat menu at the top, Statistics. Yes. After Statistics, come to Quality Tools. Yes. Now, when you come to Quality Tools, you see on the right-hand side, another menu bar is opening. Come to Gauge Study. Gauge. You see Gauge Study? Yes, sir. Just bring your cursor. Hold on. Then click on Gauge RNR Study Cross. I will tell you what is this cross. Yes, click on cross. I will tell you afterwards what is this cross. Now, what are the part numbers? Select from the left-hand side, call ID. Yes, operators, select appraiser. And measurement data, select data. Double click, yes. Now, method of analysis. We will select X bar and R. Why? Because X bar and R will show us the variance in the data. Okay, so that's why we will select X bar R. R means the range. X bar is the mean and the range, mean and the variation. Because in a measurement system analysis, we will always check the variance of the data, variance of the measurement. So we have selected X bar R. Now click on OK. Yes, everybody has clicked on OK. Hold on, take some time to generate the data based on your RAM power. Okay, based on your RAM power.
Hi, Debashish, sorry. Where did you guys get the data sheet from? I'm not seeing it in any of the links.
I have already, this data has been shared in the group long time back by IMC. You get it from the group. In the group, the material and the data file both has been sent. I had shared with IMC and IMC has shared with this. I can tell you the date also when it was shared. I can tell you the dates. Just give me a moment.
Sure, please.
Yes,
Yeah.
yes. I will tell you when it was shared. Both the files were shared immediately by Suryansh. Yes, it was shared on, just give me a moment. It was shared on, hold on. It was shared on 27th of June. It was shared on 27th of June. You will have it over there.
Okay, let me look for it. Thank you.
Yes, please. Okay. Yes, I think CB Rajan has also shared. CB Rajan, she has also made a comment on this in the group. So I think when we have the session, I would request everybody to stop communicating on the group. Okay, we can better communicate over here, unless and until there is some logistics issue that you are not getting the recorded sessions and all. For this, you have to write in the group. I cannot help. It will be IMC who will be helping you out. Okay. So now, in the session window, we have got some output. In the session window, slowly Mehta come down, slowly. Okay, hold on now. There is a gauge evaluation which you can see. Gauge evaluation, where the total gauge RNR is showing 20.05. That is, you see percentage variation. VAR means variation. 20.05 is the total gauge RNR, where repeatability is almost 13% and reproducibility is around 15%, or slight more than 15%. That means what? Between one appraiser, when he has done it twice, there is an average repeatability of 13%. And between appraisers, on an average, the variation is 15%. But our main concentration in the output will be on the total gauge RNR. That is the percentage we should mainly look at. Total gauge RNR is coming at 20%. Where for a continuous data, I told you, if the percentage is less than equal to 10%, that is fantastic. We will accept that variation. But it is in the 10 to 30% range, which is marginal. And what I remember for this particular organization, when they had this result, they had taken ideally some amount of data and they got it at 20.05, which they have to take a decision. Marginal, I told you 10 to 30% is either marginal or nominal. That is, you have to take a decision. Can we accept this measurement? But over here, 20% is halfway in the 10 to 30% range. And this organization said, if it is other than 10 to 30% range, if it is between 10 to 12 also, we can still accept. But this is almost 50% between the total range, 20%. So 20% means what? 10 to 30, it is in the middle. So which is quite high. So we ideally should not accept this measurement. So what this organization did, I remember, which I, of course, that time I was not there, but I know that what this organization did, they added some more data to this exercise. And eventually they got a result of around 7 to 9%. So they took some part of the data, one batch of the data to do this measurement. So as for this measurement analysis, 20.05 here, the organization has to take a decision whether some organization can take a decision. 10 to 30% is marginal. We have to decide whether we will allow this variation or not. But if we say, no, we will go till 20%, 10 to 20%, we will still go with the variation. If some organizations say, no, if it is more than 10%, we will not allow this. We will go for another round of different measurement in that. So that's a decision which has to be taken by the organization. And this organization had taken that decision that this total gauge RNR ideally is not acceptable because it is very much on the higher level of marginal block. So we will not accept it. Mehtab, it is clear with you?
Yes, sir.
Yes, sir. Good. So,
Hello.
Yes.
Yeah, sir. This is Jairaj. Can you repeat, sir, this repeatability and reproducibility?
Sorry. Discuss what?
Sir, during hello.
Yeah,
Sir,
yeah.
I am disconnected in between. So can you again repeat this?
Repeat what? Repeat the full process.
No. This repeatability and reproducibility, this 12 and 15s. What is the meaning of this 12 and 15?
Oh, okay. I will
Yeah.
explain. Okay. As I told you people that Minitab will give you an output. Our responsibility is to analyze the output. Minitab will not give you an analysis. Whatever data you give it, whatever option you select, it will just give you an output. Your responsibility is to analyze that. If you see, the repeatability is 12.89 or say 13%. That means what? Repeatability, which I told you, variation between the same person. That means when between appraiser A, between appraiser B, between appraiser C, they each one did two times of the measurement. On an average, between one appraiser only, there is around 13% of variability. So that is repeatability. And reproducibility means between all the appraisals, A, B, and C, appraiser A, appraiser B, and appraiser C, there are around 15% of variation between the appraisers. Okay, so that is reproducibility. When I said reproducibility means multiple appraisers, otherwise same data and same measurement unit. But our concentration, this is what I'm trying to explain to you, okay? But your concentration mainly will be on the total gauge RNR percentage, which you see it is 20.05. And if you remember, for a continuous data which I wrote yesterday, and definitely you people have written it down, for a gauge RNR for continuous data, if the percentage is less than equal to 10%, it is very much acceptable. Okay, for any organization, it is acceptable. But greater than 30%, it is clear-cut unacceptable. But 10 to 30%, you have to take a decision. That's why they are called nominal or marginal. 10 to 30%, will we accept it? So each organization can have their own prerogative towards this. Some organization might say 10 to 30%, this is 20%. That means halfway between 10 to 30, which is on the higher side. So we will not accept. Some organization can take a call that we will accept till 20%. 20.05 is 20%. We will accept till 20. 21 to 30, we will not accept. So that is another decision. And whatever be your decision, you have to write it in your quality management system or your business process management system and follow that. In this organization, I remember they did not follow this. They say, no, 20% is on the higher side. So we will not accept this measurement system analysis. So that's a total at the discretion of the organization, how you want to go with this. Yeah, Jay?
Yeah, sir. Thank you, sir. Thank you.
No problem, sir. Okay. So I will stop sharing the screen now. Thank you, Mehta, for your help. I will use my screen now. And I will go to the next exercise, which is also very interesting one. Okay. This one with a discrete data. And instead of calling names, I am asking you people to volunteer. Who can do this exercise on Minitab? Please volunteer. Please raise your hand. Okay, Dennis. Good. Dennis, you can do this. Very good. Thank you. Because whosoever I am calling, some or the other, there are some problems. So good that it was done by Mehta. And now let me do this with Dennis. But all of us, let us understand first the case study. A project manager considered 10 transactions and chosen 2 appraisers at random for gauge RNR study. The transactions were evaluated on correct and incorrect basis. You understand it's the binary data, so discrete data. For all the 10 transactions, this is a bit twisted case study. For all the 10 transactions, actual results, that is the standard, is also available with the team lead. 2 appraisers processed each transaction twice within a gap of 1 week. The results are as follows. Study the gauge RNR. So that is what we have to do. So basic idea is there are 10 transactions and the team lead, he has already evaluated these transactions. And based on the evaluation, whatever it may be, he has already drawn up a standard. That is, transaction 1 is always correct, transaction 2 is always incorrect, like this. But he wants to validate whether whatever standard is there, whether the measurement of the data with the transactions with other appraisers also are getting the same standard, whether they are also matching with the standard or not. That's what we are going to see. So he has hired 2 appraisers. One is Radha, another is a Krishna. Each one have done the appraiser two times. So we have to check in this case whether the appraisal process is acceptable or not. Okay. So Dennis, I will stop sharing the screen and I will make you the co-host. So first share the data with us. You first show us your Excel sheet.
Sure. I'm sharing now the Excel sheet.
Yes, sir. We can see. There is column AQ, AR, AS, AT, AV. Yes. Copy from the heading itself. Copy.
Yes.
Go to the Minitab screen. Yes, you are quite fast. Good. Go to Minitab.
Yep.
Look, this way you will be learning. And at one point of time, I will see that I don't have to tell you which option to select. You will do it yourself. Okay, hold on. Yes, delete everything. Very good. Now, in the session window, click on that cross. Initialize everything. At the top.
Okay.
No. Come down in the session window. You see gauge, R&R, study, X bar. Yes. Always we will do this. This is to initialize, because somebody asked me yesterday, sir, can't we use worksheets? Yes, you can do. But you see, opening an worksheet for you at times is taking so much time to generate your session window. So it will be always better to delete it and have it. Yes, Mehta?
Sir, I just wanted to ask on this C1, C2, C3. So everything was like that. Then when the data was inserted, there is a hyphen T over there. What does that mean?
T is ideally means text. As because you have entered an alphanumeric or a text figure, that's why it is coming as T. T is for text.
Sir,
okay, sir. Good. Okay. Now what you have to do, everybody follow Dennis. Dennis is now our trainer. Okay.
Sure.
So, sir, go to stat again. Click on quality tools and come down to attribute agreement analysis. Yes, click on this. Okay. Before we go ahead with this, I missed out to explain one thing in the earlier exercise. In the earlier exercise, when we selected the gauge R&R study, everything was done good. But there was an option that we selected, which was called gauge R&R study crossed. If you see it afterwards sometime, you will see there are 2 options. One is a crossed and another is a nested. What does it mean? But we selected crossed. Ideally, we will always select crossed. Not here. Hold on, Dennis. I'm not explaining this one. I'm explaining the earlier one. One small point which I missed out. So why we selected crossed? Whenever it is the same data which is being measured by multiple people, exactly same data, we ideally select the crossed option. And what is nested? Nested is, say, it is Dennis and Ahmed working in a research and development organization. And both of them were asked to measure some temperature at given point of intervals. At given point of intervals, the temperature of the solution or whatever they are measuring could change. That is called nested. So ideally, nested will not always give you the right picture of a measurement system analysis, because here we are all testing the same data. That's why we are selecting cross. Okay. Now, you have already clicked on attribute agreement analysis. Now come to multiple columns. Click on multiple columns because there are multiple columns. No. Come down. Yes. Multiple columns. Hold on. Don't move your cursor so much. Come to the multiple column blank area. Take your cursor Yes. Now from the left, select Radha 1. Hold on. Radha 1, Radha 2, double click. Double click, not like this. Yes, one after the other. Krishna 1, Krishna 2. Yes, because based on their output, we are going to measure the measurement system analysis. That's why we had to select them. Number of appraisers, come to number of appraisers, enter 2. And number of trials, enter 2. They each two. Each one has done two trials. Now, come to appraiser names and enter Radha, space Krishna. Of course, it is optional, but it is better to put the names so that when we have the output in front of us, it will be very easy for us to understand what is this output means. Come to known standard or variable, and from the left, select C2 standard. Double click and click on OK. Okay, now bring it down. Bring down, no. Hold on. Bring down your worksheet. Bring down your worksheet. Drag it down. Drag down your worksheet. What you are doing? You are in the session window. I told you to drag down your, yes, drag it down. Okay, now go to the top. In the session window, go to the top. Okay, now here in a measurement system analysis, we are always going to discuss on the assessment agreement. Okay, not on the kappa statistics. Kappa statistics is something which is a different way of checking whether it is good or bad. The measurement is good or bad. Always check it with 1 or 0. So we are not going to discuss that. That is not relevant over here. Okay. So we will always discuss assessment agreement. That is the main output of our measurement system analysis for a discrete data. Now, if all of you see, and also Dennis, you check, the first one we are checking within appraisers. That is, for respective appraisers, what is the measurement system analysis result? For Radha, she has inspected 10. Out of them, matched are 6. So her percentage is 60%, which ideally should have been 100%. Ideally, for Krishna, he has inspected 10 and his matched is 8. So his percentage is 80%. And in a discrete data measurement system analysis, we have learned it yesterday, the percentage should be greater than equal to 80% for our acceptance. So you see, Krishna looks like he's a consistent performer. His performance is acceptable. Now come down slowly in the session window. Slowly come down. Okay, now come down further. Okay, now hold on. Now you see another assessment agreement which is coming. Each appraiser versus standards. That means against the standard, how many are matching? Against the standard, for Radha, she has inspected 10 and only 5 have matched. For Krishna, on 8 have matched. So here also you see Radha's performance is only 50%. Forget about all this 95% CI and all. Confidence interval. That is not required for us in a measurement system analysis. Only the percentage is important. For Krishna, it is still 80%. So you understand, Krishna is a very consistent performer. Always he is getting till now a percentage of 80%, which is the only accepted result. Come down further. Come down further. Yes, hold on. Again, you see between assessment agreement, between appraisers now. Between appraisers, how many have matched? They have totally inspected 10. Only out of that 4 have matched. 6 haven't matched at all. So 40% is the matching percentage between appraisers. And here you understand it is mainly happening because of Radha's measurement. We are not going for a fault finding here, but we are just trying to analyze. As because Radha's performance from the very beginning is going down and Krishna is quite consistent, it is obvious that because of Radha's measurement, which is not up to the mark, the assessment agreement is not in a good thing. Now come down further. We will have one more. Yes, hold on. All appraisers versus standards. All appraisers. Over here also, out of 10 inspected, 4 only have matched. So we can understand that is also 40% over here. So in this example, we will take it that only Krishna's measurement could be acceptable. Krishna's measurement could be acceptable and not Radha. So since the R and R percentage, that is the repeatability and the reproducibility percentage in most of the cases is less than 80%, because only for Krishna it is good, but overall it is always less than 80%. We have to do a root cause analysis, which is evident that because of Radha, or whatever may be the problem, her measurement is not good. So we have to either reconduct with some new appraisals, or with a new set of data, again, we have to do our measurement. Is it clear, Dennis and everybody?
Yep, that should make sense.
Yes. Okay. So what I will do, I will stop sharing the screen. Okay. I will remove your focus permission. So this way we will do. Okay. So this we have already done. And yes, so as you can see, since R&R is less than 80%, mainly for Radha's case, root causes to be identified, and this is exactly what I said, and corrective actions to be taken. Reconduct study to assess the improvement, if at all you feel. So that's a decision has to be taken. Okay, we might feel, okay, we might replace Radha, take some other appraisal, do the assessment again with the same data, or maybe we can have some other lot of data to find out if that is to be required. Okay. So that talks about the measurement system analysis. So now what we will do, we will go into a new concept we will learn, which is called the process capability. Now, process capability, we have to understand very thoroughly first. Okay. So for understanding process capability, I will first use my white. Okay. I will first use my whiteboard to understand process capability. And let me first write it down, then I will explain, okay? Process capability, which is also signified as a sigma value or V scope. You remember when we just entered into the major phase on the 3rd day, there was a table that we followed. Which I told you that this is a globally accepted statistical table, where there were from the bottom, there were sigma values, 1 sigma, 2 sigma, 3 sigma, 4 sigma, 5 sigma, 6 sigma, where 6 sigma is ideally proclaimed as the highest level of process capability. And you have seen that process capability 1, 690,000 are the defect rates on an average out of 1 million opportunity. As we rise to 2, the defect rate decreases. We rise further, the defect rate further decreases. This way we go to 6 sigma level, ultimately where we have 3.4 defects out of 1 million, which is ideally 0 defects, almost 0 defect, 3.4 defect rate out of 1 million. You will definitely consider it as almost like a 0 defect, right? So that is the ultimate of our process capability. Now, I told you that time when we were discussing, we were talking on the table, I told you that I am not going to talk about the sigma level now. But now we will talk about the concept of sigma value and also the concept of process capability. Now, this concept of process capability is always considered in different terminologies. Okay, some people call it process capability calculation, some people call it sigma value calculation, some people call it Z-score calculation. Z is a very important term in statistics, which means a value. Okay, so any of this term ideally could be termed as a process capability. Now, what is the idea of understanding the process capability? Now, say it is Davinder Singh. Davinder Singh wants to do a Six Sigma project. Why he is doing a Six Sigma project? He is trying to improve the process. Improve the process so that the product or the services will also improve and his customers will be very happy. That is the ultimate why we do a Six Sigma project, to make it very simple. Now, if I want to improve the process, I have to attain a target which is given by the customer. Now, Satish, if you can tell me, what is the terminology that we had discussed, which talks about the final target which is given by the customer, which we have to attain? What is the target called? What is the terminology called? Target. Satish.
Hello.
Yes.
Your voice will be break. Once again, asking again, sir.
My question is, what is the terminology we discussed, which talks about the ultimate target that we have to achieve to satisfy the customer? What is the terminology called?
100%, sir.
Huh? What do you mean
What,
by
sir?
100? What do you mean by 100%? Yes, Karan? Yes, Karan, tell me.
Specification limit?
Yes, Karan, tell me.
Specification limit?
No. Who said?
Specification limit.
No. No, hold on. Who said? No.
Karan.
Hold on.
Yes, sir.
No. 2 or 3 people are talking. Hold on. Karan, please be on mute. I can see my ugly voice coming out. Okay. Karan, is it you who said specification limits? Just say yes or no.
Yes, sir.
Okay. Just say yes or no. Yes. So, Karan, are you have you logged in with a mobile and a laptop both? Karan?
No, sir. Actually, maybe some
Karan?
network issue, I guess. No, I'm with system.
Oh, okay. It should not happen here. I can see my voice coming, which is very irritating. Oh, okay. It should not happen here. I can see my voice coming. Okay. I muted you. Please check why I am able to hear my voice only. I don't know. Okay. Now, Mehtab and Ittihal, I am lowering your hands, but were you also trying to say the same thing? Specification limits?
No.
Or then?
No, it's CTQ.
Yes, that is also correct. Even if you say CTQ, I will take that. But as I told you from the very first day, that when we have our CTQ and we derive the USL and the LSL from the CTQ, that ultimately becomes my ultimate target that we have to achieve. Even CTQ is nothing wrong, because from the CTQ we derive the USL, LSL, right? So that is also nothing wrong, but I would prefer to have that answer USL and LSL. So what is the idea of process capability? The idea of process capability is to understand your current capability compared to the target that you have to reach. You have to reach 95% quality. That customer has given you a target. Your lower specification limit is 95%. Greater than equal to 95%, he has given you a target. So your USL is 100%, LSL is 95%, minimum 95% quality I want. So your current quality you need to first understand. If I come to our day-to-day life, as I always keep on talking about exams and all these things, say, my parents have given me a target to score 90%, 90 to 95% in all papers in the exam, in the professional exams. And currently, so first, this is some of the learnings which even the parents can have from Six Sigma. When we give a target to our children, do we take an assessment ourselves that whether my children are capable of attending that. Suppose I have one son and one daughter. Say, I'm just giving you an example. Both of them are studying in the same class, same standard. For both of them, I have given them a standard that you people both have to, from the next exam onwards, you have to give me at least 95% result. Say, but have I ever considered what is their current capability? When I go to understand their current capability, I see my son's current capability is only 50%. So from 50%, reaching that 95%, the poor guy will die. Whatever improvement he does, I put him in some best online tuition, best home tuition, best special classes, whatever, that poor guy will die from 50 to reach 95%. But suppose it's my daughter, she also is having the same target, 95%. At least her standard currently, her capability currently is say 75%. So for her, reaching from 75 to 95 is rather easy. Compared to my son, who will almost die if he has to reach from 50 to 95. It will be a tremendous job for him. So before giving a target, or rather not before giving a target, that's wrong what I said. In order to attain a target, understanding of our current process capability is very, very important for us to understand. Because based on that, we have to plan our improvement afterwards in the improve phase. Similarly, in the example that I gave you for my son, we have to put some much improvement processes to go from 50 to 95 if possible. But for my daughter, maybe a smaller improvement will do. Smaller improvement will do. Right? So it helps us to understand, to reach there 95%. Where do I stand now? You remember, I gave you one example earlier that in a Six Sigma initiative, understanding your current status is very, very important all the time. You will improve. Wonderful. You will improve. But with what respect you will improve, that depends on your current situation. So you have to understand it this way. These are all conceptions. If I just do a Minitab exercise, you will not understand this thing. So that's why I always concentrate on the concept first. Please be clear on the concept. Then understanding of the Minitab exercises will be very, very easy for you. Okay. So process capability tells us to understand my current process capability compared to the target that we have to reach. Where do I stand now? What is my average performance now? Then only we can ultimately assume how much improvement we have to do. Okay. Now, in order to understand the concept of process capability, I will also give you another very conceptual knowledge. Whenever we do a Six Sigma initiative or a Six Sigma project, please listen to me carefully. No? Carefully means please pay attention. That's what I mean. I know you, all of you are very attentive. I'm just telling you so that you don't forget these things. When I say I want to do a Six Sigma project, that does not necessarily mean that you always have to reach that Six Sigma level. No. Even if you reach 4 Sigma, 5 Sigma, 3.5 Sigma, that is also okay. But that should be always considered with respect to your current process capability. So if you're, suppose it is Ibtihal who is doing a Six Sigma project, and in the measure phase, she first calculates her process capability. Okay, we are in the measure phase now, process capability, where my process is very poor now. It is having too much of defects, too much of problems, too much of variations it will have. I haven't improved it, right? So it is very much in a bad shape. So if she calculates a process capability, which I told you earlier, her process capability could be very much in the lower level. It could be at 1 sigma level. It could be not even 1 sigma level. As I told you earlier, I have seen projects with not even 1 sigma level, so poor. I have reviewed one project for one person who did a black belt training with me. He did green belt and black belt. He works in Mercedes-Benz as an intern in New York City. So he came down to India and attended one of my sessions, rather two of my sessions, one green belt and black belt continuously. After doing the green belt, he liked the way it was done, so he wanted to attend my black belt only. It was with some other organization. So after he attended that, and he went back and did an Six Sigma project, and some of the things he sent to me for some review. I remember his original process capability in the measure phase was 0.77 sigma. It was not even 1 sigma. And eventually, when he improved the process, it was at 3.5 sigma level, which he finally improved. So doing a Six Sigma project does not necessarily mean, because all these things you ideally will not find in a Six Sigma material, because these are from the practitioners, from the practical standpoint, which I'm telling you. Material will be the theoretical material with exercise, hands-on, everything, which is the generic form of the material. Any material will be like this. But that's why you need a trainer to explain that. Trainer like me who will explain from the practitioner standpoint. So always remember, doing a Six Sigma project does not necessarily mean that always you have to reach Six Sigma level. Now, you say you are at 0.77 sigma, which is very much at the lower level, not even 1. Ideally, with an improvement, whatever improvement you do, can you really reach Six Sigma in one shot? That is 0 defect rate. With so much defects at the beginning, can you really reach 0? Even I am not saying that is impossible, but it is rarely possible. If you tell me, sir, my original sigma was at 1 sigma, and now I have scored 6 sigma straight away, I will tell you, please show me what out of the box ideas, what out of the box improvement you have done probably. Let me see, it could be a learning for all of us. I'm not saying it is impossible, but it is rarely possible. So what is the idea of doing a Six Sigma project? When you are at the measure phase, we are now going to calculate our initial process capability, the capability of my process, where I now stand. And after my process is improved in the improve phase, ultimately my intention will be to reach a process capability at least 2 or 2.5 sigma higher. That is very good improvement. That means if your sigma level in measure phase is 1, in the improve phase, we have to recalculate our process capability. It should be at least 3.5 or 4. If you can reach 6, that is wonderful. But always you will not be able to reach logically. So even if you reach 2 or 2.5 or 3 sigma higher, that is very good improvement. And my suggestion will be, don't strive to reach always 6 sigma level unless and until there is a push from your customer or from your organization. If you can reach 4, wonderful improvement. From 1, you have reached 4. How your sigma value has increased? Your sigma value has increased because your defect rate has decreased. And how your defect rates has decreased? Your defect rate could be decreased only by improvement to the process. So in one way, by improving the process, your sigma level has increased, right? That is what is called the sigma value calculation or process capability. So always, if you reach say 4 sigma or say 3.5 sigma, you reach wonderful improvement. But at the same time, you have to see whether the target given by the customer is attained or not. That is the first thing that we have to see. So that we will discuss again in the improve phase. So now you have reached 3.5 sigma. Sustain your 3.5 sigma for some time. Say 9 months, 1 year, whatever you feel you are confident. When you see that no, my 3.5 sigma or 4 sigma level, whichever I have attained, it is not deteriorating at all. I have checked it for 3 quarters, for 3 or 4 quarters I have checked, it is not coming down. Wonderful. Now from 4, you can try to reach 6. That will be easier for you. So similarly, in my son's case, which I was giving you an example, I should not give him a target of 95%. So the target itself is not attainable by him. So what he has to do, from 50%, give him a different target. From 50%, try to attain 70%. From 50 to 70, that would be easier for him. Reach that 70, stay there for some time, then from 70, try to reach 90. That is what we call a staged level of sigma improvement. Staged level of sigma improvement. You reach a stage, 4 sigma level, stay there for some time, can sustain that continual improvement. When you are very sure that nothing is coming down, everything is well sustained, nothing is deteriorating, I am still at 4, very good. From 4, then reach 6. It will be a much easier journey for you. This is what we do in a case of a process capability. Okay, so process capability is to understand how far is my current process capability compared to the target that we have to reach, which we ideally do in case of a continuous data. Okay, in case of a continuous data. So what we will do, we will first talk about continuous data. For continuous data, sorry, spelling mistake. For continuous data, we will calculate, first write all this down. Okay, everything is there in your material, but I am giving you a pocket note. If you can have your pocket notes in front of you, your life will be much, much easier, that I can guarantee. Because this feedback I get from people. Sir, your pocket notes helps us a lot. Okay, continuous data. For continuous data, we calculate our process capability. We calculate our process capability with a method which is called process capability index, or CPK. First write it down, then I will explain. For CPK, first we calculate CPU. Don't ask me any question now. I will explain you after writing. Okay. USL minus mean divided by 3 standard deviation and CPL. First write down everything, then I will explain. It is mean minus LSL divided by 3 standard deviation, and CPK is minimum of CPU and CPL. Okay. Whenever we want to calculate process capability for continuous data, we do the calculation using a method which is called process capability index, which is called CPK in statistical term. Now, how is this CPK calculated? First, we calculate CPU, that is process capability index, compared to the upper specification limit. What is the target? As Karan said, upper and the lower specification limit that we have. So we try to understand if my upper and the lower specification limits are this, how far my average performance is away from the target. So what for, in order to calculate CPU, that is CP upper, process capability upper, from the USL, I subtract the mean. So we understand how far we are different, and we divided it with 3 standard deviation. Why? Because if you remember the normal curve, 3 standard deviation was on one side and another 3 standard deviation was on another side. I told you 3 on one side, 3 on the other side, 3 on right side, 3 on the left hand side. And accordingly, automatically, USL is on one side of the mean and LSL should be also one side of the mean. So that's why we're dividing it with 3 standard deviation to make it half. CPL, how far my mean performance is away from the LSL or the lower specification limit. And that also we divided by 3 standard deviation. And our CPK ideally will be minimum of the 2. Why? I will give you an example. Say, now here the value comes to, say, just as an example, 1.53 and here the value is 0.57. So our CPK value should be 0.57 being minimum of the two. But why we are taking minimum of the two? If I ask now, Mangesh, what is your average marks that you get in all the professional exams? Why I am giving this simple example so that it's easy for you people to understand. What is the average percentage that you get in all the professional exam for the last 1 year? He says, sir, my average is 90, but sometimes I get 95 also. Okay, 90 to 95. But most of the time it is 90 for sure. Sometimes I get 95 also. So which one I will take for safer side? I will take the 90%, right? That surely at least 90% should always be there. Sometimes it is 95. So ideally, we cannot ideally take 90 as such, 95 as such. We will ideally take 90% of the lower of the two as the, ideally, the lower of the two we will take as a safer side. So in this case, CPK, I got a value of 0.57. Now I told you that process capability calculation, we will always have some sigma value or a Z score. And this is not a Z score. This is a CPK value, right? So how to calculate a Z value or a sigma value or a process capability from a CPK value? For that, I will go back to my material, and there is one slide. I will come back to the discussion. Hold on. Yes. There is, you see, there is a determining sigma level for data. This table is called the sigma Z table. This is called the sigma Z table. Now, if you see at the bottom on the right hand side, of course, the heading is hidden actually. The rightmost column is the CPK column. Okay, the rightmost column is CPK. With that IMC logo, it has got hidden. Okay. Now, if you see at the bottom of the screen, come up 4 rows. You see there is a CPK value of 0.57, which I have taken as an example. And against that 0.57, if you come on the left of the table, this is a statistically driven table always used in any Six Sigma initiative to calculate the sigma value. Against 0.57, there is a column which you see sigma short term ZST. There is a value of 1.70. Sigma short term is the value that you will always consider as your sigma value or your Z score, which is called 1.70 in this case. Where if you, from 1.70, if you just move your eye at the top, you see the ultimate value is 6, which is the ultimate value that we have to attain. So compared to that, we understand that we are at a very low level of sigma, and that's obvious. We are still at 1.7. So ideally, after improvement, we should go to around 3.7 or 4 sigma at least. I said at least 2 or 2.5 sigma higher you should go. Otherwise, it's not a good improvement. If you just from 1.7, you make an improvement to 2.7, it's not a good improvement. We will not accept that Six Sigma result. It will be at least 2.5 or 3, ideally. Okay. So if you see, it is 1.7, which is the sigma short term. This is the sigma value that you will actually look at as my current process capability. But if you see on the right-hand side, just on the right-hand side of ZST, there is another column, which is called ZLT, where the value against 1.70, the corresponding value is 0.20. Now, if you check any rows in the table, against ZST and ZLT, you will always see a difference of 1.5. If you see at the top, it is 6 as ZST, ZLT is 4.5. 5.9, 4.4. You go anywhere, 3.9, you see 2.4. There is a difference of 1.5. What is this? This concept is called sigma shift. Sigma shift, what does it mean? Sigma shift means, suppose it is Sadaf. Sadaf, he is trying to do a Six Sigma initiative. Okay? And while doing a Six Sigma initiative, his organization is very much interested to know, the Sadaf, could you please tell us what is our current process capability? He calculated the way, suppose he is having a continuous data, based on data, he calculated, sir, I am at 1.7 sigma now. We are at 1.7 sigma now, which is very low, of course, right? But his organization just understood that sigma level, but didn't go for improvement to the process. It has been observed globally and statistically that if you calculate your ZST and you don't improve your process further, in the long run, your sigma value will further diminish by another 1.5 sigma. It will further deteriorate by 1.5 sigma on an average. For some organization, it could be more also, for some could be marginally less also. But on an average, it has been seen that if you calculate your process capability now, but you don't improve your process actually, you just calculate it and left there. In the long run, your sigma level or your process capability or your Z score will diminish or deteriorate further by another 1.5 sigma. Now the question might come, sir, what is that long term? What is that long term? Long term varies from organization to organization. If it is CB Rajan's organization is having a very mature process. For them, 1 year could be a very long term. But say it is Dennis who has just started an organization where the process is yet to be matured. It will take time for the process to get matured. Ideally for him, even 2 months could be long term. So he cannot wait that long. It will deteriorate slowly. First, it will deteriorate. So we have to understand, ideally, you will now say, sir, why we will wait for a long term? Because ultimately in a Six Sigma initiative, we have calculated our sigma value to check where do I stand now. But now we are going to improve our process, right? Absolutely. You are going to improve your process. So it does not mean you have to calculate your long-term sigma value anytime. So ideally, when you calculate your Z value or process capability, you have to ideally calculate your ZST. So in many areas, you will see just Z value. That is actually your ZST value. That is the sigma value, the process capability, the sigma value, the process capability, or the Z score that you have right at this moment on 30th of June, 21:18 IST time. This is the sigma value that I have. This is my sigma value that I have. Sigma value ZST is the sigma value that we always compute. Okay. Now, when I talk about sigma value, CPK, we have already talked about that CPK, in order to calculate your process capability or sigma value or Z score, we have to always calculate our CPK, the way I have shown. Okay. Ideally, you don't have to calculate it manually. Minitab will calculate for you, but I thought I will explain this with a concept for you to better understand. We will do the exercises after this. Other than CPK, there are also two more concepts, which is called CP, which is called process capability potentiality. But I would say, as a Six Sigma professional, our concentration should be more on the CPK and not that potentiality thing. If I say, Mangesh has a potential to score 100% in all his exam all the time, but actually he scores 90%. So which one you will take? You will take that 90%, right? So 90% is what the capability index has shown you as CPK. And from the CPK only we calculate our process capability of the sigma score. There is another term which is also calculated in the same way like CPK, which is called PPK. PPK is not a process capability index, but a process performance. But why it is called PPK and why it is called process performance? Because in case of a process capability index or CPK, we do this with the sample data. And for PPK, we do with a population data. That's why we call it a process performance, because it is on the total population data we are calculating this. The way of calculation is the same. But in most cases, I will say 90% of the cases, any Six Sigma initiative that we will do with a CPK way of doing things, because we will always handle a process capability using a sample data. So what I will do, we will now go to, I think the concept is clear with all of you. I will first explain. First, we will do the process capability work, one exercise with the, or rather what I will do, let us do one thing. Let us work out the discrete way of doing things also in the similar way. Let us write down the discrete way also. Let us explain that also. And maybe then we will take a break. And after coming from the break, we will do the two exercises. Okay. So for discrete kind of data, also write it down. For discrete kind of data, the process capability is calculated by a method which is called defect per million opportunity, or which is called DPMO. What is sorry, DPMO? Now, in order to calculate DPMO, there are a few things that we will need. This calculation method is very, very different. This calculation method is very, very different. Okay. Here, we have to understand few things. You can write it down. Okay. There is also some example explained in your material also. But let me explain this better. Number of defects you have to consider. Number of units. Number of opportunities per unit, number of opportunities, DPO, which is means defect per opportunity. Defect per opportunity. Let me write it down properly. Defect per opportunity, which is called DPO. And what is DPMO, which is equal to DPO into 1 million. 1 million. Okay. So these are the things that we will need. What I will do, let me bring it up over here. Okay. And oh God, so it is gone. Okay. Let me write it down once more. Let me write it down once more. We have, for discrete process capability, we have to know number of defects. Please write it down. Number of units. I will explain this with a very good live example. Number of opportunities. Number of opportunities per unit. What is happening with my typing per unit? Then I calculate DPO, which is defect per opportunity. Defect per opportunity, let me write it down. Defect per opportunity, and what is DPMO? This DPO into 1 million, because it means defects per million. Now, let us understand with a very good example. Okay, very easy example I will give you. Suppose it is Satish. Satish is trying to fill up a form. There is a form which I have given to Satish. The Satish, please fill up this form. Now each form, and there are total 15 forms which Satish has to fill up. 15 forms. Okay. So the total number of units are 15 forms. Fill up 15 forms. Okay. Now, each form has 10 fields in that. Each form has 10 fields, or rather I will change the example. There are 10 forms and each form has 15 fields. Each form has 15 fields. So total number of opportunities per unit is how much? Total number of opportunities per unit is 15. 15 are the opportunities per form. Each form has 15 fields. That means opportunities per unit are 15 fields. So what are the total number of opportunities? It is 15 into 10. 15 into 10 equal to 150 opportunities total. There are total 150 opportunities which Satish has to fill up. I have given him 10 forms. Each form has 15 fields. So basically, he has to fill up all the forms and all the fields. So in all, he has to fill up 150 fields. Now, if I try to understand, if Satish has to commit a mistake is what? If Satish has to commit a mistake, what is the maximum number of mistakes that Satish can he can make in filling up all the forms? He can ideally make 150 mistakes. He can commit, that is in all the 10 forms, in all the 10 fields, or all the 15 fields in each form, in total 150 fields, he has made a mistake in all the 150 fields. That is maximum he can do. So the total number of defects possible under the current situation are 150 only. But Satish is a very intelligent guy. Okay, so he has just committed 26 defects. Satish has committed 26 defects out of 150 opportunities. So the DPO will be defect per opportunity, which is 26 divided by 150. Total defect per opportunity. The total opportunities are 150 and defect per opportunity will be 26 divided by 150, which is equal to a figure which I know, 173333. This is the figure of DPO. And how much will be the DPMO? DPMO will be DPO, that is 0.173333 into 1 million. 1 million, which is equal to 173333. This is the figure which comes to DPMO. Okay, normal calculation, multiplication. So now, like the way we had calculated for continuous data, for discrete data also, for continuous data, we had a figure called CPK, where from the CPK we went to the Z table, and from the Z sigma value table, we found out against that CPK value, what was the ZST value. Similarly, for a DPMO value also, against the DPMO value, we have to go to the same table. We have to go to the same table to find out what could be our ZST value. Now, on the left-hand side now, if you see, there is a DPMO column. CPK was on the right-hand side, DPMO was on the left-hand side, okay? Now, in the DPMO, if you come from the bottom, some 7 or 8 rows, if you come up, you will see there is a DPMO value of 1,84,000 something. And then there is a value of 1,58,000. So 1,73,000 will fall somewhere between these two figures. You will not always get the exact match of the data. So some amount of approximation is always welcome. You can always do some approximation. Okay. So your 1,73,000 something will fall between 1,84,000 and 1,58,000. What is the ZST for 1,58,000? It is 2.5, and for 1,84,000 it is 2.4. So we can say probably that for 1,73,000 something DPMO, our ZST value will be somewhere between 2.45, somewhere in between. Somebody can say 2.46, because any approximation with the 2 decimal point after decimal, that is permissible. So somebody can say 2.46, 2.47, 2.43, 2.45. It does not make much of a difference. Okay. So I will say, just for a safer side, it is 2.45. So this is how we learn that from a CPK, how we understood that ZST, and for DPMO, how we understand that ZST. So what we will do, we will now, oh, it is perfect 9:30. So we will go for a break of 15 minutes, and then we will come back and we will first do our two exercises on process capability, one with a continuous data, one with a discrete data, and then we will move to other cases as applicable. Okay. So let us take a break of 15 minutes and come back exactly after 15 minutes. Okay. Thank you. Welcome back after the break. I think all of you are back, right? Could you please put a thumbs up just to check whether all of you are back so that I can start? Yes, sir. Dennis is there. Preeti is there. Very good. Mehtab and Ibtihal, Dennis. Okay, what about others? Funny is there. Good, good. So quite a few of them are there. So I think we can start our session. Others will also join in the meantime. Good, good. Thank you. Somebody is chatting. Yes, Saheen is also there. Wonderful, wonderful. So let us start. Otherwise, what will happen? Nobody is there. I will just keep on talking. It does not make sense. Okay, good. So before going into the break, we were primarily discussing on the concept of process capability to understand the current process capability compared to the target that we have to reach, which we ideally do for a continuous set of data where we calculate the CPK, and from the CPK value we go to the Z table, and then we understand what is the sigma short term or the sigma value or the Z score or the process capability. And based on that, we then have to finally talk about or plan our improvement that we will do in the improve phase. Similarly, for a discrete data, we will ideally calculate the DPMO, which is the defect per million opportunity. And based on that, we will finally calculate again the ZST or the sigma value accordingly. The process remains the same. So what we will do now, I think the concepts are very clear with all of you. It will be more clear when we do the exercises. The first exercise that we do over here is for a continuous data, process capability calculation. Now, who wants to do it? Just please raise your hand. Who wants to do it? Nobody? Okay. Sadaf, very good. Okay, now Mehtab, you have already done one. Let me give this opportunity to somebody else. So I will come back to you. Okay, Karan, maybe I will do the exercise next with you. Okay, the next exercise I will do with you. Let me do the first one with Sadaf. Sadaf, you can hear me, right?
Yes, actually, sir, I am Ali Raza. So
Oh.
right now I am using my wife.
Oh, I'm so sorry. I'm so sorry. I'm just calling her name. Sorry about this.
Okay, it's okay.
So you can right click against your name and make your name Ali Raza. It will not be good. No, it will not be good if I just call her name all the time. Doesn't look good. So you could right click against her name and change it to Ali Raza at least for today. You can do that. Right click. Yes. Good.
Yes, done, sir.
Yes, yes. It makes sense, sir. Otherwise it doesn't sound good.
Actually, I was looking for this option, but
no problem. No problem. You have to just write. Okay. Now, let us understand this exercise first, all of you. Then we will do this with Ali Raja, and the next one I will do with Karan. Okay. The cycle time in minutes for each transaction in a day on both the shifts was collected. The SLA for the cycle time of the process is 60 minutes. Calculate the process capability. The process capability of the cycle time we have to calculate. Okay. So there are two shifts of data which you can see. We have to calculate the process capability of the cycle time. So what I will do, I will stop sharing the screen and I will make Ali Raja the co-host. Ali sir, please share your screen. Show me your exercise data file first. Wonderful, wonderful. Now go to the left-hand side. Let's go to the left-hand side. Yes, go further. Yes, hold on. There are two sets of data, column E and column F, cycle time and shift. No, go to the top. Yes, copy from the heading. Yes, with the heading you copy. Yes, come to the bottom, sir. There is a tactics of copying also. So come down till we go to the end of the data. No blank rows you should copy. No, but just check whether you have, yes. Good. Copy. Copy, go to your Minitab, share with us your Minitab screen. Share with us your Minitab screen, go for a new share, click on new share, your Minitab screen will appear. You're not able to see your Minitab screen as yet. You have to click on new share. Then only your Minitab will appear for us. Yes. Now first delete all the 3 columns of data. Yes, delete, block it and delete. Delete, delete. You can block it together and delete as well. Okay, good. Now go to row number 1. No, don't copy from here. Go to row number 1. You have to be very careful in copying the data. Go to row number 1. It is showing 7. Go to row number 1. Yes, now copy from here. Yes, paste it. Paste. Absolutely. Good. Very good. So all of you definitely are following Ali Raja, and you people have already copied cycle time and shift, right? Good. Now, Ali, you are from Pakistan, right? Ali? You are on mute.
Yes, sir. I am from Pakistan.
Oh, yeah, from Pakistan. From Lahore, or what did you say? From where?
Kashmir, sir.
Oh, you are from Kashmir. Okay. Good. Now, good. So, what we will do, we will have to do this exercise now. So, what we will do, go to statistics, come to quality tools, and come to capability analysis, and click on normal. Yes. Now, single column, there is only one single column of data based on which we have to calculate our process capability, which is cycle time. So from the left, double click cycle time. Wonderful. Subgroup size, enter 1. Enter 1. Why? Because cycle time subgroup is only 1. Subgroup, I told you, subgroup is one column of the data is called one subgroup. Okay. Now, very interesting thing. Come to upper specification limit and enter 60. Do you remember, Ali Raja, why we are entering 60 over here?
60 is the upper.
Yes, because in the case study, it was given that the SLA was given by the customer was 60 minutes. And who gives the SLA? SLA is given always by the customer, service level agreement. And similarly, upper specification limit is also given by your supplier, by your customer, right? So that's why in the upper specification limit, we have marked it as 60. So SLA means maximum. SLA is always the maximum which we will take. So 60. Now click on OK. Nothing else. Click on OK. And hold on. Yes. Could you please come down, bring your cursor a bit down on the session window? Hold on now. Hold on. No. Go up. Yes. Hold on now. Now, Ali Raja has prepared a fantastic chart that we can see, fantastic graph, where Ali Raja and everybody can understand one thing. This graph looks like a normal graph, isn't it? Ali sir?
Yes, sir.
Looks like a normal curve. What
Yes,
does it mean? That means this data of cycle time does not have any
standard special variation.
Absolutely does not have any special cause variation. Very good. I feel so comfortable when you people also talk in these terms. So I feel that yes, people are understanding the things. That means there are no abnormalities. So one thing is for sure that the data is a normal data. This is an additional test that we have done. Now, if you see on the right hand side, there is a CPK which is coming as 0.77. When I said, if you say CPK is 0.77 and also your CPU is also 0.77, how is it possible? Because if you remember, I told you ideally when we wrote on the whiteboard, ideally CPK is calculated being the minimum of the CPU and the CPL. But here there is no CPL, nothing is given. Only the upper specification limit as an SLA has been given. So there is no question of the minimal thing. So your CPK will be equal to your CPU, right? Clear, Ali Raja?
Yes, sir, clear.
Yes, good. Now I will remember this figure, 0.77. We have to now find out the Z value now. So I will take your co-host permission and I will now take my screen back and I will take you through the Z table. I will take you through the Z table again. Now, if you see, I will bring my cursor down. If you see at the bottom of the screen, if you see 0.77 CPK is appearing and come on the left corresponding to your ZST. It is showing 2.30 or 2.31, whatever you can say, whatever, it does not make much of a difference. So over here, your ZST is 2.31. Now let us go to the exercise that we have done. Now you see, your ZST is 2.31. Forget about the DPMO. DPMO, we are not calculating over here. Okay, because this is not a discrete data. 2.31 and your ZLT, which has been also calculated just to showcase to you. 2.31 minus 1.50 comes to 0.81. Let me see in the Z table again whether it is coming. You see 0.77 CPK. Your 2.30 is your ZST. And what is your ZLT? 0.80 or 81. So you understand, whatever you calculate as your CPK, it is coming the same thing as we have in our process capability from the Z table onwards, right? Good. So what we will do now one discrete exercise we will do, and we will do this with Karan. So I will stop my sharing. I will make Karan. Where is Karan? Yes, Karan. I will make you the co-host. Yes, Karan, I have made you the co-host. Could you please share with us your exercise data file first?
Yes, sir.
Yes. So here, okay, I made a mistake. First, let us understand. I will stop your sharing for the time being. I will take to my exercise and we will first share the exercise. What is the exercise? Let us understand. That I didn't tell you. The number of defective tractors produced has been collected for a period of 1 year. The data is stored in columns tractors produced and tractors defective. Good. The maximum percentage defective we are willing to accept is 5%. Determine the capability of the process. Remember, in the probability distribution, we have learned whenever we have a defective option, it is a binary data. So it will be a binomial capability. If you remember, for probability distribution also, for a binary data, we need a binomial probability distribution. Similarly, for a process capability also, we will be doing a binomial process capability. Okay. So what I will do, I will stop sharing my screen and where is Karan? Karan, I think, oh, you are already the co-host. Yes, please now share with us your exercise data file. Yes, tractors produce and tractors defective, column P and Q. Column P and Q. Copy both these two sets of data with the heading. Column P and Q. Yes, with the heading. Yes. Copy, no blank rows. You will get an error message. Copy, go to your Minitab, share with us your Minitab so that everybody can see. Good. Share your Minitab as a new share. Yes, paste it, sir. Wonderful.
Yes, sir.
So Karan has very rightly copied it over, pasted over here, tractors produce and tractors defective. And we have to calculate our process capability based on the tractors defective. It is very clear for us to understand. So what we will do, go to assistant. All of you follow Karan, go to assistant, click on capability analysis and hold on. Hold on. You will get a chart. You will get a chart coming out of Minitab. I will show you.
Right.
It's taking a bit time. No problem. Okay.
Yes.
Now, your data is a attribute data or a discrete data, right? Correct?
Yes, sir. Discrete.
Yes,
Attribute.
and you have a defective items to check, right? So you
Yeah,
click on
right, sir.
binomial capability. Click on binomial
Got it, sir.
capability. Absolutely. Now, number of defective items column. You tell me which one you will select from the left.
This one, sir.
Absolutely. Good. Very good. Practice defective. And come to column of subgroup sizes. Column of subgroup sizes. Click there and select tractors produced. Because select tractors produced. That means from within tractors produced, I want to check whether the tractors defective, what is their process capability. And in the maximum, enter 5. Because it is given in the exercise, the maximum is allowed is 5% tractors defective. Click on OK. Click on OK. Let the equation, let the result come over there. It will take some time based on everybody's RAM and processing time. Let it come. It's taking too much time, but can't help. We have to wait.
I guess.
Hold on. It is coming. Hold on. Nothing to worry. Okay. Now, don't. Yeah. It's okay. Now, just check on the right hand side. There is a ppm and dpmo value. If you see 13573 right hand side. ppm, dpmo 13573. I told you that in case of a no, don't have. Yes. Process capability 13573. ppm or dpmo value which is equal to 13573. So now process Z, to be very honest, in this exercise, Minitab is showing us our CLT figure, which ideally it should not show. To be very honest, I don't know why it is showing our this figure, because in the earlier exercise and all exercises we always see the ZST value. But okay, it is showing 13573, and as we can see, there is a process Z which is being already calculated as 2.21. Remember these figures. I will stop your co-host and I will use my screen now to show you what is the value of this. Okay, I will go to the Z value again. It is 13573. Now, if you see the DPMO column on the left-hand side, come up 2 or 3 rows, 4th row from the bottom. There is a column which is equal, there is a figure which is equal to 13900 something. 13903, the DPMO is the ZST value is 3.7, and you see the ZLT value, it is 2.2, exactly what we are getting in the value. So 2.2 is the ZLT value, but we will be concerned about the ZST value. So ideally what we have to do for 13573, which is almost like 13600, it could be either 3.7 or a bit more than that, maybe 3.71 or something like this, 3.71 or something we can say. So approximation, as I said, we can always do an approximation. So whatever be the ZLT value that has come over there in the Minitab, we have to simply add 1.5 over there to get that 3.7. 2.2 plus 1.5 comes to 3.7, because ultimately you have to put the ZST value in the picture. Okay, so that is what we have done for this particular exercise. Here with you, Karan and everyone.
Yes, sir.
Okay. So yes, thank you. So what I will do, I will. So your thing is gone. So now what we will do, we have already done this exercise. Let's see how it is there. Yes. Process sigma level is around 3.7 and DPMO is 13573. So which is perfect. That is what we have discussed and that is what we have generated ideally. So this talks about the process capability. Okay. Karan, actually, I remember after seeing your name, I think you didn't join yesterday maybe, right? Were you there yesterday?
Yeah.
You were there?
From
Oh, acha,
no,
acha,
no,
right. You might
I
have
was not
missed.
available.
Oh, no, it's okay, Okay. Just seeing your name, I recollected something. You remember on the last day when you joined, you were when I was discussing QFD, you talked something about house of quality. You remember?
Yes, sir. Yes, sir. Yes, sir.
Yes, house of quality you were referring, which that house of quality term, I didn't remember, to be honest. But later on, I was trying to understand something which we in quality management generally called HOQ. OQ, we call it HOQ. So then I was referring that, okay, was Karan referring to HOQ? Then I was referring to some of my notes and other areas. Then I saw that HOQ is nothing but the house of quality or the QFD to an extent which you were referring. So both the same. Okay.
Right.
Uh,
Yes, sir.
yes,
sir.
but sometimes what happened in the QFD, we ideally bet on figures. And in the house of quality or HOQ, we always call it HOQ. But what you said is also correct. HOQ, we don't refer to figures more, but more on symbols we do. More on symbols. But the overall effect is the same. Just to showcase the relation, which one having a very strong relation or less relation, something like this. So just to let you know, I didn't remember it yesterday, but today, just seeing your name, suddenly it struck me that, okay, I think this guy was talking on something that day, which at that point of time, I just forgot what is the house of quality thing. I didn't seem like I heard this word. Then I was referring to that, okay, HOQ is there. HOQ is nothing but house of quality. So it is the same thing. So thanks for taking that out. Thank you. Okay. So now we will talk about one concept which is called yield in the measure phase. What is the concept of yield? Yield actually means the non-defective part. The non-defective part against which those units we don't have to do any rework or scrap or rectification work. That is what we call an yield calculation. Okay. In case of yield calculation, there are generally few ways of calculating yields. We will discuss about 4 kinds of yield calculation. The first kind of calculation is called the multiple step process of yield. Multiple step process. Suppose there are 3 steps. Step 1, step 2, step 3. Generally, these are calculated ideally in manufacturing organizations. But to be very honest with you, I haven't seen this to be calculated very much on a regular basis. But even if you do, you can do in any of these ways. Okay. Now, in this example, you see there are 3 processes, 3 steps, step 1, step 2, and step 3. In step 1, quantity bills in are 100. Defectives came out as 5. Defective bills corrected are 4. So how many are eventually corrected? Okay bills out are how many? 99 out of 100. 1 is marked as defective. So we have 99 as okay bills out. So our step yield over there is 99% or 0.99 for step 1. Yield is also calculated ideally in percentage. Step 2, again there are quantity bills in 100. Defectives are 3. 2 bills are corrected. Again, it is 99% and also the step yield is 99%. For step 3, quantity bills in are 100. Defectives are 2. Defective bills corrected are 1. Again, it is 99% bills out and step yield is also 99%. So if we ask you, what are the step yields respectively in all the 3 steps? You will say in each of these steps, it is 99% each. There is another calculation of yield, which is called a classic yield. How it is classic yield calculated? Classic yield is calculated by multiplying. Yes, Mehta?
Yes, sir. So I was just referring to this step 1, step 2, step 3. So in step 1, there are 100 bills. So out of that, there were 5 defectives and 4 are corrected. So in step 2, would it be 99? Like I don't understand.
No, it's not a continuation. It's not a continuation.
Okay.
I think you are thinking of it's just a different steps of doing things. What you are trying to say that the output of step 1 will ideally come back to step 2. It is not that way. It is some separate steps actually. Okay, what you said is also correct. We could have an example like that also. Okay, good. Okay, so classic yield, how it is calculated, it is step yield of step 1 into step yield of step 2 into step yield of step 3. That is product of step yield 1, step yield 2, and step yield 3, which is 0.99 into 0.99 into 0.99, which is equal to 0.97. So you see step yields for each step is calculated separately, and classic yield is a product of all the steps that we have. As Mehta was trying to give that example, it could have been also that way, that all these steps are related to each other. So whatever OK bills out, it could be 99 coming as quantity bills in for step 2. Accordingly, we can also have it. So that way also we could have it. But this is just as an example we have. Okay. Now, another way of calculating yield is called a fast pass yield. What is a fast pass yield? Let us understand this table below. Total bills checked are 100. This is from a purchase department. This example has been taken. Total bills checked are 100. Wrong name spelling are 6. Wrong address are 3. Wrong quantity is 1. And taxation terms not clear are 4. So total defects are how many? 14. So how many are fast pass? 86%. 14% are defects. So fast pass yield is 86% straight away. Okay. Now, if I want to go for another way of calculating yield, which is called a rolled throughput yield. How is rolled throughput yield calculated? It is calculated by calculation of the first pass yield of each of the steps that we have. Suppose there are also 3 steps, where the step 1, the first pass yield is 86%. For step 2, it is 90%. And for step 3, it is 95%. So your roll throughput yield will be a product of the first pass yield percentage of each step. That is 0.86 into 0.9 into 0.95, which is equal to 0.73. To be very honest with you, only in IMC, we are using this yield we just showcase. I hardly have seen, because I work with around 6 organizations, I have told you, I haven't seen yield being discussed in any of the other organizations, whether in a green belt or even in a black belt. Ideally, in a green belt, we don't discuss this. We ideally discuss either in a black belt or a master class. So hardly these are discussed. So, but I felt that when it is there as a subject, let us also give some idea on this. So if at all people wants to calculate this, they can calculate it straight away. So this is what we have understood in the major phase of the Six Sigma methodology. What we will do now, we will now step into the analyze phase of the Six Sigma methodology, which is my favorite phase. My favorite phase is the analyze phase of the Six Sigma methodology. And this analyze phase will ideally take you the maximum time to complete, ideally. Okay. Now this analyze phase, I want to define it that way. It is ideally divided into 2 parts. One is the root cause management part. Another is the relationship management part. So today we will continue with our root cause management part. In the root cause management part, these are some elementary slides which I don't want to touch base. The first formal technique that we want to use in a root cause management part is the brainstorming technique, or the brainstorming session, or the brainstorming meeting. What in a brainstorming session we do? Suppose it is Ali Raja who is doing a Six Sigma initiative. It is me, Davinder, and Dennis, and say Ibtihal. We 4 are his team members, and he is doing a green belt or a black belt project, Ali Raja. So he is the leader. So ideally, in a brainstorming session, which should be a formal meeting, that means a formal meeting request should go to all of us, that we are here, we should assemble on such and such day to discuss this. Discuss this, I will tell you what to discuss. And everybody should attend. If they feel, if Ali Raja feels that I am the junior most person in the team, I will not be able to contribute much, that is the biggest mistake. Even the junior most person can always contribute the best if required. So all of you have to come. All the 100% of the team, if present in the office, should ideally come for the meeting. Now, what is the purpose of the brainstorming session? In a brainstorming session, everyone in the team should explore what are the root causes which they feel are causing the problem to happen. What are the root causes which they feel are causing the problem to happen? Now, all of us, we know what are the problems that we are going to improve. That means we are aware of the problem in the process. In the brainstorming session to start with, we explore what are the root causes which each one of us feel are causing the problem to happen. So I will give my 4 root causes. Say, Ali Raja himself will give 4 root causes, Davinder will give 4 root causes, Dennis will give 4 root causes, and also Ibtihal will give 4 root causes. So all 5 of us give 4 root causes, and when we express our views, there should be no criticism. There should be no judgment. No, that is bad, that is good. What root cause you are giving? No discussion. Let everybody express. Let crazy ideas come out. Let out of the box ideas come out. After all these discussions are done and all the root causes are given by all these 5 people, we total now have 20 root causes. Now we will start our discussion whether these 20 root causes are really the root causes. So that needs to be discussed, rediscussed, filtered, refiltered. Many of the root causes could be common also between us. So this way, the root causes have to be discussed, rediscussed, filtered, refiltered. The discussion, I will say, is the best way of formulating a root cause final list. Okay. We can also go for a multi-voting. That is, when discussing, we are not able to come to a conclusion. We are not able to come to a conclusion which one to finalize as root cause. Okay, maybe we are not able to agree. So we can do one thing. In a meeting room, we can write down all the 20 root causes on the whiteboard and ask every team member, that is myself, Ali, Davinder, Dennis, and Iftihal, all of you come and you please put a tick against those which you feel are the good causes. This way we can go for a multi-voting. But I personally, based on my experience, I will say discussion and rediscussion is the better way other than the multi-voting. Your multi-voting could also go wrong. You might have voted for root cause number 1 and 7, but you have ignored 2, which ideally could be the most or the best root cause that you have. So every root cause should be discussed in detail, and your brainstorming session should be broken up and should not ideally exceed 1 or 1.5 hours each day. You can maximum have it for 2 to 3 days, break it up into 1 hour each. This is how a brainstorming session is ideally done. Good practice. Now, also a brainstorming session can be segregated. Brainstorming session root causes could be segregated as how relevant it is from the organization standpoint and how frequent this root cause can happen. Based on this, we can mark it as high, medium, low in a range of 5, 4, 3 ratings also, or 1, 2, 3 ratings also. And whichever root cause we feel are having the maximum rating, we can prioritize that. But in spite of having this relevance and frequency and the multi-voting scenarios, I will strongly recommend, based on my experiences in various organizations, brainstorming session, discussion and rediscussion, finally coming out with root causes which everybody in the team agrees. Everybody should give a thumbs up. Yes, these are our final root causes. There will be no discussion after this. So myself, Ali, Davinder, Dennis, and Ibtihal, all 5 of us will give a thumbs up. Yes, these are finally the 10 root causes maybe, because some of them might not be root causes, so we will omit those. Some are very good, we will accept those. Some are common, we will take those. Based on this discussion, rediscussion, filtration, refiltration, we have finally say as a number, we have got 10 root causes. Now with these 10 root causes, we will now proceed further. After the brainstorming session is done, the first quality tool or quality analysis which we are going to use is called the cause and effect analysis, which many of you might have used in your organization. Fishbone analysis, Ishikawa analysis, fishbone diagram, Ishikawa diagram, cause and effect diagram. I prefer to call it a cause and effect analysis. Now, we have got, say, 10 root causes. These 10 root causes, now we have to group or categorize under respective heads. How many are under person related area? How many are method related area? How many are equipment related area? How many root causes are related to materials area maybe? How many are measurement? Sorry, how many are measurement related root causes? How many are environment? There is no hard and fast rule that you have to always classify under these headings. You can have any headings, any category. I'm sorry. You can have any categories whatsoever. Any categories whatsoever. At one point of time, I'm talking about 10 to 15 years back, we used to always classify these root causes under 6 headings: man, machine, method, material, measurement, and mother nature. 6 M's. But now, in the current evolution of total quality management, every organization can have their own criteria. There is no hard and fast rule. I have seen nowadays organizations making a category called innovation, making a category called work culture. It was very logical when they explained to me. Okay, so over here you can see why this is necessary. Over in this example, if you see the fish head, whatever be the fish head, it is showing ovality in 10 mm bore on the right hand side, whatever it might mean. It's a manufacturing kind of problem. So this is the effect, and these are all the causes which are coming as in fish bones. So you see over here, maximum of the problem, maximum of the root causes are grouped under method and equipment, and more, and also in person and materials. For measurement, there is nothing, and for environment, there is only one. So we can understand accordingly, we have to concentrate more on the method related area and equipment related area, and then person and materials related area. Over here, I want to write down one thing to you just for your own knowledge. You remember when I discussed this particular equation initially, or expression, y is equal to f into within bracket x. You remember on the very first or second day we had this expression, and then I explained to you that time, and I told you there are many things written down the line which you don't read now. I will tell you afterwards. Now, I told you that in the define and measure phase, we have understood y as the output, f as the process or function, and x as the input or inputs. You remember this, which I have already told you. In the analyze phase, the magnitude of this changes to an extent. In the analyze phase, it changes to an extent. Okay, what is that? The y over here is called the effect, and the x over here is called the cause or the causes. Overall, the meaning remains the same. Effect is nothing but the output. Causes are nothing but the inputs, but we signify it in a different way. So always remember, in the analyze phase, y is the effect. F always remains the process or the function, because that is what our focus is always. And x are the causes. Okay. Again, in the improve, it will further change. In the improve, it will further change, which I will discuss again afterwards. But nowadays, okay, afterwards I was telling. After the cause and effect analysis, we now understand which are the causes, which are the root causes which are causing the main problem to happen. But if suppose Ali Raja has come out with these root causes against person, that negligence of the people is one of the major root cause of this problem. And I told Ali Raja, you have identified negligence as one of the root causes. So finally, that has to be improved, right? So Ali Raja will say, yes, sir, I will improve that. But how will Ali Raja improve the negligence of the people if he doesn't know why people are negligent? For method, there is tool blunt. Davinder will say, yes, I will improve the tool blunt. How will he improve if it does not know why there is a tool blunt? So understanding the granular root cause is very, very much necessary. For this, we do another analysis, which is called a twin analysis, or which we called a YY analysis or a 5Y analysis. Ideally, I prefer to call it a YY analysis because some people get confused with the 5 number. What we have to do, as Ali Raja said, negligence of the people is one of the reasons of the problem is happening. I will ask him why there is a negligence. He will say, sir, people are reluctant to work. Why people are reluctant to work? Sir, because people don't have a salary increment for the last 2 years. Why people don't have salary increment for the last 2 years? Sir, because there is no sales budget. Why there is no sales budget? Because, sir, there is no proper revenue. Why there is no proper revenue? So what I am doing? I am going to the grassroots level of the root cause. I'm going down. I'm digging in. This is what we do in a YY analysis. Sometimes it is also called a 5Y analysis. Why? Because generally it has been seen that if we ask ourselves 5 times why, we generally go to the grassroots level of the root cause. But there is no definite indication that by 5 times why you will always go to the grassroots level. I have mentored projects where I have gone till 14 whys. Again, also I have done another project where I remember we have done till 3 whys. After that, we could not dig further. So always remember, in the current evolution of total quality management, whether we do ISO, whether we do CMMI, whether we do Six Sigma, whether we do total quality management, cause and effect analysis and YY analysis are 2 of the most important quality analysis that we do nowadays for all initiatives. So it is so important these 2 analyses are. Now, I will give you 2 examples of the YY analysis. Okay. And we will stop after giving these examples. Tomorrow we will do a review of this and then we will step into further areas. So the first example is from a manufacturing organization. You see, there is a question. Why are you throwing sawdust on the floor? Answer is, because the floor is slippery and unsafe. Why is the floor slippery and unsafe? Because there is oil on it. Why there is oil on the floor? Because this machine is dripping. Why the machine is dripping? Because the oil is leaking from this coupling. Why the oil is leaking from the coupling? Because the rubber seal inside the coupling is worn out. We could have further drilled down. Why the rubber seal is worn out? But just as an example, we have kept it till the 5th stage. Just as an example. But as I said, we could have further drilled down. Why the rubber seal is worn out? Again, we will go and get another answer. Again, we can ask about that and drill down further. But just as an example over here, say, just understand this way, that this rubber seal, this is the final why we have got. So you understand the rubber seal getting worn out is the main problem. So in the improve phase, when we improve the process, our improvement has to come from the rubber seal to get either replaced or removed. Then there wouldn't have been any leaking. If there wouldn't have been any leaking, oil wouldn't have been dripping. If the oil would not have been dripping, there would not have been any floor slippery and unsafe. And if the floor would not have been slippery and unsafe, we did not throw sawdust on the floor. So you understand the improvement is coming from the bottoms up approach. From the bottom, the improvement has to come. So when we go for improvement in the improve phase, our improvement should ideally come from the bottom level, the most granular level of the root cause that we have. This is what we are going to discuss in a YY analysis. What we will do, we will stop our training for today because I don't want to rush, because these are very conceptual things. We will discuss about this today. There is another example which we will continue tomorrow, and then we will quickly review this, and with one more analysis, which is not so compulsory, I will say, not mandatory. And then we will eventually go to the relationship management tomorrow, and we will do sufficient number of Minitab hands-on tomorrow. Okay, so tomorrow is Friday. So before we go for our weekends, we will have sufficient Minitab exercises. Okay? So I will stop my presentation for today, stop my lectures for today. So thank you very much, everybody, for your time as always. So we will meet again tomorrow, same time, 8 p.m. India time. Till such time, good night, and thank you very much, everybody.
Thanks.
Thanks, sir. Thank you very much.
Good night.
Sir. Thank you. Good night, sir.
Thank you.
Good night, everybody. Bye. Bye. Thank you very
you.
much. Thank you. Thank you very much.